Ladies and gentlemen, the tiny DevOps guy.
Hello, and welcome to episode number 4 of Tiny DevOps. I'm your host, Jonathan Hall, and today I have with me Peter Morlion, who loves fixing and improving legacy code so the next software release can be less stressful. Peter, welcome.
Hi, thanks.
Can you go ahead and tell us a little bit more, elaborate on what I just said? What's your fascination with legacy code? Maybe what do you do professionally and your history?
Sure. So I actually, if we go way back, I'm not the kind of kid that grew up programming. I'm fairly late to the game. I did like computer games, but when it was time to choose, go study, I chose for political sciences, and only later I did computer science in night school, and there I discovered I like programming. And then when I was looking for a job, I just took the first opportunity that I could as a programmer, and it was working on an existing application. And so there was a lot of refactoring, there was a lot of writing new code and new features, but there was also refactoring. And there I sort of started noticing that it's very pleasing to, after like a year or maybe 2 years, you start really knowing the application, the ins and outs, the odd quirks. And so I sort of started noticing, I don't really mind what they call brownfield development or the legacy or refactoring legacy code. And along the way, more and more, I got new jobs and went from place to place, and there was always some refactoring going on more than there was new code. And so while many of my colleagues hated legacy code and just liked starting stuff from scratch, I just noticed sort of, I kind of like this stuff, so maybe I should try and make a career out of it, or at least focus on that. So more or less coincidentally, I just found out that was fun. So that's how I got into liking legacy code.
That's a nice story, and I agree. I think most people try to run away from legacy code. I also am kind of drawn to it. I feel like it's always a fun challenge to try to make the code better without changing the functionality. It's an interesting constraint to work on. So today we're going to talk a little bit about technical debt, but I would like for you, if you don't mind, to define that term. I mean, you talked about legacy code, but what is technical debt to you?
Yeah, great question. It's like everyone, or at least all developers, seem to know what legacy code is, but asking a definition, it makes it a lot harder. It's like, oh, it's spaghetti code, or it's code that doesn't work, or and digging into this, there's like the definition by Michael Feathers, who says it's code without tests. But I believe we should see that more in light of when it was written. It's from his book. I forget the name of the book.
I think it's Working Effectively with Legacy Code.
Yeah, that's the one. So I think it was written in a time where unit tests and automated tests weren't as normal as they are now, even though I've encountered quite some code bases where it still seems something new. But I tend to disagree with that. I don't know, maybe Michael Feathers himself disagrees with that now, because I have encountered code with a good test suite with quite some coverage, but where we still feel, this is legacy code, it has a lot of technical debt, it's a mess, it has to improve. So a good one I heard recently is legacy code is valuable code you're afraid to change, and that sort of covers the emotion or the emotional part with legacy code. We have some code and it's valuable, either it's making money or it's just useful. We still need it, even if it just doesn't create income. But we're afraid to change it. Each time we need to change it, we're afraid we're going to break things, or we just don't like it because it's difficult to work in. So that's a good one. And another very good one is by Andrea Goulet from Corgi Bytes and Legacy Code Rocks. And she says, legacy code is code without sufficient communication artifacts to explain its intent. So the first one is more about the emotional aspect. We're afraid to change it. The definition by Andrea is more about, it's more a technical definition because it explains, it might have tests, but it might be lacking documentation, which still makes it hard to work with. Or it might have thousands of pages of documentation, but it's outdated. So the fact that she talks about communication artifacts, that can be anything. It can be documentation, but it can also be code comments. It can be unit tests. And I think that's a great definition because that's usually what we feel becoming code, and we don't know what is this code supposed to do, what is it doing, and we have to start digging and reading and making a mental model. So those are two great definitions to me.
That's good. And what are the risks of technical debt? So we have some code that we're afraid to change. How does that affect us, especially from a business standpoint? If I'm maybe I run a business and I don't rely on the software, what are the risks involved?
Yeah, because that's the core of it. Because even if we're afraid to change it, and I mean that has no business impact, but I believe legacy code can have a real business impact in many ways. The obvious one is, each time we change something, we create bugs that we didn't know we were creating. We fixed something here and then created a bug somewhere else, which can have an impact on the user base of the company. And there's probably some way of quantifying that. It can mean money lost. There's also time lost. Each time a team or a developer needs to add a feature or change a certain feature, if it's difficult code to work with or they're afraid to work with it, they're gonna work slower than if it had been good clean code, easy to read, easy to maintain. So, and time lost means money lost as well, because it's an opportunity cost. The developers could have been working on the next feature, but instead they're working days on days just to add a button that does something that seems fairly simple. So there's that. There's also less obvious things like security. You might be stuck on an older platform or an older framework or library which has security issues now, and might even be impossible to upgrade because of other dependencies. So you can get stuck in an old version, and it can have all kinds of implications. Another thing is it's hard to get to know the application, so there's slower onboarding. If a new member joins the team, it can make a difference between getting up and running in 2 weeks or only being productive after 6 months. And the final thing that is often forgotten, because we tend to look at problems in a technical way, but there's also, again, the emotional aspect. Too much legacy code and technical debt leads to burnout in the worst case, but just it can decrease the morale of the team, and worst case, people just come and leave after a few months. And I've seen this in action, where there's a constant change in the team because people don't last longer than a year, which is bad for business again, because you have to onboard the new developers each time, and people have to get to know the application. They'll more easily introduce new bugs by accident because they assume certain things or they don't assume other things.
Yeah, that's good. You've brought up some ideas, some concepts that I hadn't actually considered. The emotional aspect, especially of technical debt, is something I've. If someone had asked me, I probably could have said that, but it wasn't top of mind for sure. And so that's really important. Is it ever appropriate to have technical debt, to make the choice that we're either not going to refactor this thing, we're going to leave this legacy code as it is, or we're going to maybe even introduce legacy code? I don't know if you would intentionally introduce legacy code as you've defined it, but we often choose as a business or even an individual to take on financial debt to buy a house, a car. Is it appropriate to make that choice as you've defined legacy code and technical debt, or should we always avoid it?
Yeah, I think there can be situations, but you have to do it deliberately. I mean, there's this categorization. There's intentional debt and unintentional debt. Things just happen. Even if you have like you're putting all this energy in making good documentation and tests and clean code and well factored and all. Inevitably, a dependency gets a security issue. Maybe you didn't know about it until a year or two later, or things that were clear to the team at a certain moment might not be later, and so they sort of didn't think to document something, or new patterns emerge. Like the singleton pattern was, when I got started as a developer, was one of the design patterns you had to know. Fast forward a few years, and it's it's considered a bad practice, except for maybe some edge cases. So you might end up with code that 4, 5, or 10 years later, even though at the time we felt good with the code, our feelings have changed now, and we don't think it's readable or maintainable or good code. So that's unintentional code, and that will happen inevitably. It can be also, sometimes it is a good idea to create intentional technical debt because there's a deadline in the project, so things have to go fast, or maybe you haven't found a better way. So you're writing code and it works and it's under tests, but you've tried refactoring it, but then it doesn't work anymore, and you're sort of stuck. Then sometimes it's a good idea to just we'll leave it as it is and revisit it later. The problem there is that often revisiting later never happens. But
Right.
in the end, we're still working for a business, or maybe we're running a business. So there's more than just the pressure to write good code. There's also pressure to get something out. There's pressure not to waste too much money on things. There's all these different factors. So sometimes it can be a good idea to take the quick route and create some intentional technical debt.
Do you have any examples of a specific time when technical debt was a serious problem?
Well, I have a great example. It wasn't great to work with, but so there's this company, which I won't name, and they have a big application for making reservations, for booking trips. So it's in the tourist sector, and it's a gigantic application. I believe it was a monolith, but it existed from like 7 or 8 pieces. It had about 8 databases, and it had, I guess, between 5 and 8 teams as well, all working on that. And management acknowledged, okay, it is a mess. We're stuck, and we need to fix it. So they got in some contractors, some freelancers, to create a refactoring team, which I was part of. And well, basically didn't work out because you can't have one team saying we'll do the cleanup and the others just chugging along. And the issue there was, again, each time business or the business team would ask a feature, the relevant team, one of those 5 teams would get to work, and it would take a long time. It would usually be riddled with bugs. And this wasn't a fault of the team. I mean, there were some capable people there, seniors, some juniors, but you have to imagine there was a lot of business logic in SQL scripts. And so they had stored procedures referencing other stored procedures, referencing again other stored procedures. And many of these stored procedures were thousands of lines long. So to find your way into that, even for a small change, is just frightening at best. And when you make a change, you don't really know, especially as a newcomer, because we, the refactoring team, were new. You don't really know what you're doing because you might be editing in the wrong place, or you might be doing it in the right place, but there might be 2 or 3 other places where you need to make the change. And so this had been going on for years probably, and a lot of developers just left, especially the better developers who saw this and saw there wasn't going to be any real change. So they just left for something better.
Mhm.
So what you're left with is people either choosing for the cushion job, or you get stuck with developers who don't have this enough skills to really change the project or turn it around, which is the Dead Sea effect.
Yeah.
And I think after 6 months, just about everyone in the refactoring team just left.
All right. So technical debt can be scary. How do we know if technical debt is affecting us? Maybe you've just joined a new team, especially, and you don't know the details of the company and the code base yet. How can you tell? What are the signs to look for?
Well, of course there are tools that can measure this. I know, like in the .NET space, there's Endepend, which actually just gives a score of technical debt, and even can calculate more or less like how many hours or days of work you have ahead of yourself to fix it all. But there are also other metrics like, code coverage, code churn. There's all kind of things that you can measure to see how bad is it in my application. But there's also just talking with the team. Again, that emotional aspect, seeing if people like working on the code or if they hate it. Maybe count how many bugs there are after each release, or you don't even have to count it if there's like a lot or people feel it's a lot. Maybe there are only 5 after every release, but there are 5 big ones each time, and people feel this is way too much. Just the feeling of we're facing an issue here that needs to be fixed. That could be a way of measuring that. I have this metric of myself, which I call the disaster release ratio, and it's you count how many disasters or bugs you have after every release, and divide that by the amount of releases you have, and you want to get as small a number as possible. So if you have if you've done 5 releases but you had 25 bugs over that period, the ratio is 5. If you have 1 bug and you released 5 times, it's 1/5, so it's a lower number. So just getting a feel of that is a way of measuring.
So let's say that we've identified that our team is affected by legacy code. What can we do about it? How do we start tackling this problem?
Yeah, writing tests is, like, to me, the number one technique to tackle your legacy code. At least it's a starting point. So when we encounter legacy code and technical debt, we probably want to change the code and improve it. But before we do that, I believe we need a way of knowing that when we make changes, we aren't breaking stuff, because often in legacy code things are constantly breaking, and that's one thing we want to stop. So adding automated tests is just about the starting point for me. And sometimes to add automated tests, you might need some little refactoring or tweaking before you can even add the tests, but I'd keep that at a minimum, which is why sometimes I wouldn't. So there's a big debate, the test pyramid, where at the bottom of the pyramid there's unit tests. So you need a lot of unit tests because that's the base. And the more components you start testing together, the less of those kind of tests you need. So usually you need a lot of unit tests, a little less integration tests, and even less end-to-end tests. With the legacy code, that's often, or sometimes at least, that's not as easy, because adding unit tests requires a certain design, maybe so you can inject dependencies or mock certain stuff, and that's not always as easy. So I've had projects where I've done it more or less the other way around, where I started writing a lot of end-to-end tests, even though you get then I think that's called the testing ice cream cone or something, where it's the inverted pyramid.
Yeah.
But you make do with what you have. So having a lot of automated tests, regardless of the type, just gives you a safety net to start refactoring. And I actually have a success story there. At another client, we had a similar. It wasn't as bad, but we had a similar issue where this application, each time things changed and were released, something would break. And the first thing we did, we started writing a lot of postman tests. And basically, we wrote as much as we could for that. And then when we felt we had enough things covered, then we started changing the code and we could run our postman collection and see, oh, I've broken something. Let me debug that or revisit that. And it really helped. So that is the starting point, writing automated tests so you can change code, run the entire test suite, maybe in a CI build, and verify that you've reduced the risk of breaking anything. Another technique which I haven't used yet, but I find a very interesting idea, is the wall of technical debt, which is an idea by Matthias Ferraz. His idea is to, when you encounter something that you feel this is an issue, this is a problem, you write it down on a post-it and you put it on the wall. And everyone does the same. And if you encounter something that's already on the wall, you can add a dot, so dot notation, just add a dot, and dots will be added on the post-its as you go along. And that starts making visible which pieces you need to tackle first. So you can add, I believe he then adds estimations on how much work it would take to improve this code. And then it even makes it visible to business people which pieces or which features or which pieces of the code are a problem and how long would it take, and then you can start evaluating, this is low-hanging fruit, it won't take long, but it seems we're very frustrated by it. And that's a good idea then to start picking which pieces you should be working in first, and probably also which pieces should we be writing tests for first. And then start refactoring, get agreement on the team on how you want to refactor. Maybe variables need to be renamed in a certain way. Maybe there's coding styles, maybe there's architectural styles, maybe you want to introduce the repository pattern, but these are things you need to agree on in the team. And once you have that, you can start working towards that.
So what can we do if maybe management hasn't bought into this idea? I mean, and I think to some extent, practically everybody's in that situation. I mean, maybe even management agrees we have technical debt, but they never want to give it the full attention that developers want, right? So what can we do if we are feeling the pressure of technical debt in a way that our project manager or upper management is not? What can we do?
Yeah, the wall of technical debt, which I mentioned, is a good idea to make it at least visible. You could even, I think Matthias Ferraz mentions that if each dot on the post-it represents half an hour, you might even make it quantifiable where the business or the manager can see, okay, the team estimates this takes, for example, 5 hours to refactor, and they've spent 50 hours on it. We're just losing time, maybe just refactor and get it over with. Mm-hmm. That could make it visible and maybe help you convince them that it's in their interest also to refactor, because just complaining about clean code and technical stuff often doesn't resonate with business people. I think what you need is find a common ground to explain what the issue is and why we need to refactor. There's the idea of technical debt, explaining we're taking on debt like financial debt and we need to repay, or things will just get worse in the long run. Although there seems to have been some other ways of looking at that recently, because business people are usually used to taking on debt, and it's something they can plan for, and it's fairly normal. So there's other metaphors also in the financial space where, now I'm not a financial expert, but someone compared it to an investment that isn't hedged. So if I understand correctly, you can invest in, say, stock or shares, but and thinking things will increase, but then You never know what the market is going to do. Things, the shares you bought might decrease in value, and then there's some kind of way of insuring yourself against it, which they call hedging your investment. And you of course you pay for that as well. So if the shares increase in value, you'll win money, but you'll win less, or you'll have less profits than if you wouldn't have hedged the investment, because you have to pay for hedging that investment. But if they lose in value, you won't have lost as much. So it's a sort of insurance, and you pay for insurance as well. So you could compare technical debt to that as well, and that resonates. At least that's the theory of the author of that article. Resonates better with business people, because now we're talking about risk, no longer about debt, which is something they can plan for, they can manage, which is foreseeable. We pay this amount every month. While risk is something that business people don't like. They want predictability, right. And a debt is something predictable, but a risk isn't. So that might resonate better. And in general, I think we should find, I need to think more about this, but I think we need to find ways of communicating on a common ground. So maybe even if you're talking with some manager who loves doing marathons, you could compare technical debt with starting fast at the start of the marathon and running very fast, and then of course you still need to do 30-40 kilometers. You'll have a hard time, and you might even have to give up. While if you just find a pace and you can continue that pace for 42 kilometers, then that's probably a better idea. We need to get out of our technical comfort zone and find connection with business people so that they understand why we're complaining about clean code. If all else fails, I would sometimes recommend just refactor anyway. Okay. Take ownership of the code as a developer or as a team. Business is asking you to implement a feature, and they don't and they shouldn't really care how you implement it. So if I need some plumbing done in my house, I don't care how the plumber does it. It just needs to be fixed. I mean, if there's a leakage, just fix it, and I don't do it according to the rules of the game or what the best practices of plumbing. So I think business can expect the same from us, that we implement a feature according to the best practices of our trade, of our profession. So if they're pressuring us for delivering by the end of the week, we should be prepared of pushing back, or just when you find time in between, refactor anyway. And maybe I shouldn't say this, but I have done this where a technical lead told me not to spend time writing unit tests, and I just did it anyway, and that's just the way I feel comfortable writing code. So sometimes we should just take ownership of the code and say, we're going to do it right and good. We're going to refactor this piece, and you don't need to ask business, we need 4 weeks to refactor this. You need to do, continuous refactoring, they call it. You need to do it continuously, bit by bit, baby steps. You don't need to ask, and it's unrealistic to ask business for like a week or 4 weeks. We won't be delivering any business value. We'll just be refactoring stuff. So, which in the end does create business value because it makes your work easier and more efficient. But it's unrealistic to ask it from them.
Good advice. Good advice. Where can listeners go for more information if they're struggling with technical debt and they want to learn more about what we talked about?
Yeah, so there's the Working Effectively with Legacy Code by Michael Feathers, which gives some great also technical techniques like extract classes and interfaces and very, very specific ways of improving your code. A lot of the blog posts by Martin Fowler also cover topics on improving and changing code. And if you like working in legacy code, then I can recommend Legacy Code Rocks or the Legacy Code Rocks community. It's a Slack. They have a podcast. They have online meetings. You can find them at legacycode.rocks. I believe they also organize MenderCon, which is like a online at this moment conference on legacy code, and they have this idea there are makers and there are menders in programming. So, and there's a place for both. There are programmers who like making stuff from scratch, and there are others who like taking something that has been built and improving on that, and even if it's in a bad state, get it in a good state again. So those are the menders, and it's actually Andrea Goulet, which I mentioned in the definition, who is one of the founders of Legacy Code Rocks.
And finally, how can people follow up with you if they're interested?
Well, you can just Google Peter Morlion, because it's a fairly uncommon name, and you'll probably find me. So I'm at Twitter. I'm on Twitter at Peter Morlion. I also have 2 blogs, which might seem strange, but I have petermorlion.com, where I just write about anything, technical usually, but anything I want. And I have redstar.be, which is my my company, where I specifically blog about legacy code and technical debt.
Very good. Well, thank you very much, Peter, for coming on today. It's been an interesting and educational conversation. I hope the listeners have gotten something out of this. Yeah, thanks so much.
Thanks for having me.